Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, my team is gonna share about algorithm page replacement. Algorithm page replacement consists of 4 things. First, optimal policy (OPT). Second, least recently used LRU. Third, first in first out (FIFO). And the last one is clock policy. For the first one is the clock policy. It requires the association of an additional bit with each frame referred to as the use bit. When a page is first loaded in memory or reference, the use bit is set to 1. The set of frame is considered to be a circular buffer. Any frame with a use bit of 1 is passed over by the algorithm. Page frames visualized as laid out in a circle. Okay, so as you can see, the first page is 6. So we add 6 in the column, and we add the asterisk. That shows that we cannot simply remove it. Okay, next we add 9, and it continues until 3. We add 3. We need to remove one of the number with the asterisk. So we unlock all the number, and then we add 3 and asterisk it. The 2 number above is not asterisked. Okay, so then we simply follow the rules, and yeah, we're done here. Okay, second is the least recently used LRU. It replaced the page that has not been referenced for a longest time. By the principle of locality, this should be the page list likely to be referenced in the near future. It's difficult to implement. One approach is to tag each page with the times of last reference, and this technique requires a great deal of overhead. Okay, so as you can see, at first we add 6 and 9 and 8 as usual. Then we when we want to add a new number, we need to view the least recently used from the current number. And we see that it is 6. 6 has been the least recently used. So then we add 3 in the 6th place. We replaced it, and we continue to add each other. And same as to the bottom, when we add 4, when we want to add the 4, we view as the least recently used number, which is 9. 9 has been the least recently used number. So we add 4 in the 9 in the column consists of number 9, and it continues until the end.
Alright, let us continue for the next replacement algorithm, which is first in, first out. So first in, first out, we treat page frames allocated to a process as a circular buffer. Page are removed in round robin style. Simple replacement policy to implement. So page that has been in memory the longest is replaced. So let's look at the box here. First we let the first number inside the box, number 6, and then 9, 8, and number 3. We just replace the number 6 with 3 because 6 is the longest in the box. And then for number 9 and 8, we just replace the number in the box, and we don't need to rewrite the number in a box. So we can see here, we just replace the number with a new number if there is a different number appear. So for the optimal policy, it requires the association of an additional bit with each frame. So when a page is first loaded in memory or reference, the use bit is set to 1. So we can do page frames visualized as laid out in a circle, same like before for number 6, 9, and 8. And then for optimal policy, if the same number appear, we need to rewrite the number in the same box below the number. And what we can analyze here for number 4 and 9, we just replace the number with number 3 at the first box, first column in the box. And then that's all from us for explaining about replacement algorithm. Thank you.